Yes, good. Okay, so should be having a lot of Okay, so today what we're going to do is that we're going to do checking on your practical questions, which you have already done. You have to show me so far what is your work. Okay, last previous questions, which is on last week, week three, week five, and week four. Okay, now week six, I need to revise back what we have given you on previous week. Okay, so also please note down the submission of your practical as well, yeah. uh, and then I need to see if you have already done that this question which we have assigned you last week. You can actually present it in the class and we shall see how you implement that. And also in the meantime, if you haven't really completed the work, you may continue now. In the meantime, I want to actually take all the files, the source code which we have used during the class today. I will attach it and add it into your coursework. Okay, I mean in Google Classroom. So in the meantime, while you are trying to sort out the files for your presentation about last week, have you done it? Any updates on what you have done last week? I'm talking about the practical questions which I have assigned to you. Done it? Any problem?
Uh, no, no problem.
No problem. So you managed to do it?
Right.
Hmm. Okay. So while you sort out your files, and then we see your presentation and how you do it, I uh, I will attach all the files that is required so you can see it, and then you can try and run it to see how that recursive can be uh, uh, can display what kind of results. Okay, so you can see and have an idea for what to do for the next this week. Okay, so just give me a few seconds to attach to your Google Classroom. So in the meantime, you sort out your own setup for your presentation. Okay, okay, be right back. Let me just attach that files first. These are your questions, right? We want to see this one, efficiency. This one is done. This one, yeah. See this first, and then we see this one. All right. So in the meantime, let me get the files. Yeah, I'll attach it to you so you can see. Did I give you material for week 6 last week? I did, right? The source code? 1, 2, 3, 4, 5, 5. Oh yeah, okay. So this time is week 6. Okay, okay. Yes, I did. Mm. Practical trigger require sample codes. Yeah, okay. So basically, this is for chapter 7, week 7. 7, 5, 6, 7 critical solution sample codes. Okay, so if you can see, I have added the week 7, chapter 7, week 7 sample codes. Yeah, please have a look. I for week 5, week 6. This is week 6 now, but I put it as week 7. Yeah.
Okay.
Mm-hmm. Let's see what file I missed out for week 7, week 6. Okay, so I have added that for week 7, all the lecture notes. Now week 6, but I'll see what I have not added for today. Today lecture, which is supposed to be week 6, right? So if I missed out, I'll put it under week 6. But if I have already put it under week 5, so it's fine. Um, we'll see if I missed out anything on week 5. Yeah. So with that, we will look into our practical question. So we're supposed to go for practical 5, 5, 5 to the 6, right? 5. Link implementation of collection of ADTs. 6. Recursion. Okay, today is supposed to do recursion. Hmm, okay, let's see. 7, 7 is sorted list. Let's look at the question for link implementation and collection of ADTs. Okay, so that is for last week lecture, right? Which is under, yes, so today we are going to do link implementation of ADTs, this one. uh, this topic, as in this one for your practical. Okay, next week will be this one, recursion. Practical 5 will be for today. Last week is this one. All right, so this one basically you need to have array. Refer to ADT array list class within the chapter 4 NetBeans project. Would you be able to add any more entries into the list once you have added the default capacity number of entries? So this one basically you need to uh, practical questions, right? Theoretical questions. So this one based on your practical, would you be able to add any more entries if you set the number of entries as default capacity? B, discuss how you can rectify the problem identified in part A and then implement the solution. Okay, and then next question is 2A, 2A, 2, okay, 2A here. A set of collection of distinct objects, typical operation on a set include. These are the things that you need to have, features, add, to add new element to the set, remove an element from the set, check subset is to check another set is a subset of the current set, union add another set to the current set. Okay, that's why union. Intersection returns a set with elements that are common in both the current set and the given set. It is like a subset, like a set in between, right? Intersected. Is empty. Check to see if the set is empty. Okay, that one is basically how you implement ADT. Next one, 2ADT. ADT set would be Boolean add. Okay, remember what are the function for this one? You need to just write a specification for what is the function for that. Mm-hmm. All right, so this one I gave you, right? Remember? It is specs for the set of ADTs, ADT sets. A set is what? Boolean ADT, what is this for? Boolean remove the element, what is this for? Basically, all these are, this question is theoretical, this and this, right? Okay, so what about this one? A set is a collection of distinct objects. Typical operation on the set include add, remove, is empty, to check if is empty. Okay, maybe this one is basically how you could write a simple code for this one, just a simple to indicate add, remove, check subset, union, intersection, and is empty. All right, B. So implement the set ADT, which is tier. Use array-based implementation. You may include any necessary utility methods for your ADT, set of ADTs, which is here. Okay, so first you define what is this, and then you implement uh, for this method, this sets of ADTs in your code. I think just a simple version. And then C, write a driver program to test your implementation of the set ADT. D, modify Java interface and class from part B. Okay, this one is basically how you would solve this problem, right? Okay. Modify Java interface and class from part B such that your implementation provides an iterator to the set object. Then include a method in your driver program that uses the iterator to display all the elements in the set object. Okay, so this one is that you only need to implement this hash next methods of the Java Utility Iterator Interface. So it says refer to table 4.1 for description of the methods. Okay, like this. Okay, so that's it. That is for practical 4. 3, this one you should already done it, right? I think
I
Novel has done this. Yes, you have
yeah.
submitted. Mm. This one I did not ask you guys to do, right? So, okay, this one. Practical link implementation of collection ADTs. Implement the ADT stack by using link chain with external reference to its top node. Use the interface stack interface from chapter 4. Okay, so you have example of that. Use the interface stack interface from chapter 4. This one is today. This is for you to do it for next week, which is week 7. Write a recursive method, count up. Okay, I have actually given you the example of code in your coursework, which has a count up method, I believe, that display the count up from 1 to n. Okay, let me see, where's that? Where is that? Okay, gonna count down, count down, count up, right? Let's see where's that file? Code chapter 6. Count down, count down, count down. Where's your count up? Hmm. Where is that? Count down. This is count down Java. Okay, look at the code here. This is example of count down. Okay, count down. The one that is requested to do is a count up. All right, this is to show, yeah, recursive, right? Okay, so I give you all these codes. Please try it on ya to see what is the function, how you can implement that. Okay, wait. Next up question. Write a recursive method. Count up. This is what you have to do. Okay, for 6. Because the sample what we have just now show you are all count down. That display for this one, count up, display the count up from 1 to n, where n is a positive integer. Okay, so a hint here, a recursive call will occur before you display anything. Okay, how are you going to achieve that? So looking at your countdown, okay, we want to make a count up. Instead of going down, you want it up, okay? So see if you can manipulate the code and see how you could implement this, number 1. Number 2, a recursive method that takes 2 integer and finds the greatest common divisor. Okay, complete the extra challenge question in practical 2 if you have not done so. So this one is to use Euclid's algorithm. So I haven't taught you guys this one, I think. But this one we're going to touch next week, yeah? So number 3, write code to compare performance of 3 different implementation of Fibonacci numbers using recursion, iteration, and array. So this is Fibonacci a while ago you're using a Fibonacci using recursion, right? You haven't done iteration and haven't done on array. Okay. So the fun question for practical 6, write a recursive method display backward that writes a given array backward. Consider the last element of the array first. You may add your code to chapter 6. You may add your code to the chapter 6 19 project recursive display array. I think I also give you guys that recursive. Where is that thing? Yep, this is the one. This is a sample code. Okay. So this is the one which we had shown you during the lecture, that you implement the array using three public static void function. Okay, that actually display array one, which is printing out array first for A, and then print out rest of the array elements halfway through, which is B, and then display array recursively prints array first until the last, and then prints array last. Okay, and then C, display array 3 recursively prints the left. Before was right, now it's left subarray, and then recursively prints the right subarray. Okay, so this is left and then right after that. All right, so these are the example of your array. I have given you this, you can try it on and see what it gives you, and then based on this example you can try to solve the question that is inside your practical for this chapter 7. Yeah, let's see where's that question. Simple listed guys. Question number 5, write a recursive method count nodes that counts and returns the number of nodes in the chain of linked nodes. We add your code to the chapter 6 NetBeans project simple list class. Okay, so that is practical number 6. Okay, anyway, we will do this next week. An idea what you should be looking at. Now, for now, I need to see your answer for and problems this one. Any problem for this one? This one, Noel has submitted, right? Noel, this one I already mentioned about last week as well.
Which one?
Efficiency of algorithm.
Oh, yeah,
Yeah, this one you're done, right?
yeah.
Mm. Okay. Can you show? Can you project your screen and show this one first, and then after that we go for the next one?
Um,
Yeah, please share your screen. Let me turn off first and stop presenting. Yeah, no,
oh, but
show us that that which one with that you have already done that. This one, this question, efficiency of algorithm. This. Hmm.
okay. So,
Mm. Okay, so first one would be, please explain.
so the first one is algorithm A. Um, so this is the input I insert into the algorithm, which is 1, 10, 100 until 398,000.
Incrementally. Mm.
So to run all this. the last one, it takes 0.011 seconds for algorithm A. Then we go to the next algorithm, which is algorithm B. So yeah, it took longer than among the most, it's 3 seconds, whereas
Mm.
the algorithm C took the shortest time, which is 0.001 seconds. Yeah.
Okay. And let's look at the question again. Write a Java program that implements the three algorithm in chapter 3, algorithm A, B, and C, which you have done, records the average execution time, which is referring to how much time they execute 10 iteration for various values of 10, 100, and 1000. The program should display a table of the running times on each algorithm for various values of n. Okay, so, all right. So that is your efficiency of algorithm practical number 3, right? Okay, can I see your code? I'm long array. Uh-huh. And the start time to break my time. The algorithm is the line. Turn to the program A. Mm-hmm. And then run algorithm B. The time goes to this is the print line. Algorithm B. Print line. So you declare calendar, start time equals to calendar, Gregorian calendar, end time equals to new. Mhm. Your long array would be set as long array 1, 2, 3. Okay, this one is already specified, right? Then your algorithm system print line, and time equals to Gregorian calendar, which is that. Mm. Then print second for algorithm A, then second second. And then this is an out trend line. Next one is algorithm C.
Oh, I think I put double end time.
Uh, yeah, double, right? But still, it runs, huh?
Yeah.
Did it have any effect? Same system double time. Time taken double. Oh, you put double there. Hang on. Oh, yeah, you already have that, right? Time taken. Okay, double end time. That time taken mills minus get time mills. Okay, system front line, time taken progressively, time taken seconds, and then that is C. Okay, record end time, record start time. Start time, start time, end time. C, start time, end time. This fantasy doesn't conflict, huh?
Oh,
Redundancy. Can you see down below? What is this?
oh, it's the method.
Okay, this is your logic conditions, which is your what you call a base case. Okay, you're using iteration. So, what does the question says? Using iteration, is it? Uh, where is it? Yep, okay. Based on iteration. Okay. See. Int equals to 1. I equals to 10. I equals plus some. Minus 1. Mm-hmm. Mm-hmm. It is similar to all the rest of the algorithm A, B, and C. Mm. Okay, where is your output again? Let's see output.
Okay.
Okay. All right. Okay, thank you. That is your question 3, was it? Question 3, is it? Yes. Practical 3. Okay, let's see. Is the work here? Question shared with me. Let's see my file. Gosh, cannot hear me. Okay, Calvin, can you share your work for practical 3? What is your progress on that one? Can
Yeah,
we
wait.
see?
Okay, wait.
So hang on, yeah. You need to share. Share your screen if you have, yeah.
This practical, this question 3, the
Mm,
algorithm timing thing.
yeah. Mm,
Yeah, this I just run it first.
mm.
Yeah, run it is the code shows the calculations and the timing here. Only for the 10, 100, and
Okay, can I
1,000.
see a code? Just scroll. Oh, you set it until 10,000.
On, I did
Just
until 1,000.
1,000, right?
The question asks
Yeah.
until 1,000, right?
Question asked. Mhm. Based on 10 iteration for various values and of n, 10, 100, 1,000. Okay, wait, let me see your question. What is your code? Yeah, 10, okay. 3, math. Yeah, very strong. Yeah. Iteration 10, okay. S I equals to 0, I less than iteration I plus plus. So iteration you set it to the values of 10, 100, and 100, 1,000. And then into 0 I is iteration less than iteration I plus plus time A and time minus start time. Okay, down please.
Until here only. The
Mm,
algorithm ABC is here. Yeah,
mm. Yeah, that is the condition, right? Can I see?
the condition
Mm.
from the notes.
Okay, your output.
Outputs here.
Just, yeah.
These are the results of the calculations, and then this is the time for each of the for the each of the num iterations
And
or algorithm.
are you add in all your sample codes in there as well? Huh? Multiplication Java, timing algorithm mills.
The when we submit, no need those sample code.
Mm. Okay, and is referring to the 10, 100, and 1,000. And is 100. Everyone is this. Everyone says this. 100 for A is B is that 1,000. Okay. Yeah, and also different ways has different people has different ways of presenting data. Okay. All right. Thank you.
Okay.
Next one. What else we have missed out? This one we did not do right. This one done. So Okay, this one is. Did I send you guys this one last week? I did, right?
Uh,
Yes, that is for practical 4 is for week 6. Practical 4 is for week 6, right? Okay, so this is basically theoretical. Would you be able to refer to the ADT array list class within the chapter 4 NetBeans project? Would you be able to add any more entries? Okay, you cannot see. I'm reading on my own. Wait, when I start that share them, right? The question. Yeah. Okay. Okay. So next is the practical 4. I gave you guys this one last week, right? This one is basically theoretical. A is theoretical, right? This one is, as you can refer to the ATT array list class within the chapter 4 NetBeans project. Okay. So would you be able to add any more entries into the list once you have added the default capacity number of the entries? This is you can answer is theoretically, and then discuss how you can rectify the problem identified in part A, which is here. How you rectify this? Because if array, you can actually set default capacity for the array, and also you can set find solution to basically allow it to expand when there is a new element to be added in the array, right? We discussed about that last week, how you can do that. So there are various ways. Here we discuss how you can rectify the problem identified in part A and then implement the solution. So basically you answer how do you rectify this is that by giving us a sample of source code that can actually add up the number of array size to allocate for new array being added into the array. Okay, so how can you rectify the problem identified in part A and then implement the solution? So there should be a code to represent this particular question for solution. Yeah, I think we have seen that before, the question. Yeah, we have the several codes which relates to how you could expand the number of array size based on allowing to actually allowing addition of the new element into the array. Okay, so that is B. So, have you done it? Did you manage to do this? Find a solution, B?
uh, well,
I think I
You
know. Not
managed
yet.
to?
Not yet.
Not yet, but you have an idea of how to do this? Yes? This one, yes. This is basically what you have seen here. There is a sample code. I believe I gave you an array list class. There's an array list class, right? And then if your value for capacity of the number of array entries is set to default capacity, that means you set the value. Then the question says, would you be able to add any more entries? Okay, now what do you think? Would you be able to add any more entries if you have added default capacity in your array? What do you think?
Oh,
no.
Yes?
what's the code again? Sorry.
Based on last week lecture, what do you think? Would you be able to add? What do you mean?
No.
No, right?
Yeah.
Yeah. So would you be able to add any more entries in the list once you have added the default capacity? Default capacity means you set the value of your array into what value. Okay, for example, you set it to 5. So that should be only allowed 5 items to be or elements to be inserted in the array. Basically, this question says, would you be able to add? if you put the default value? Obviously not, right? You need to put it as n. That's why you set it as n, so the value can expand if you are adding any more element into the array. So there is a solution been given during the chapter last week, chapter 4, 5. Last week was 5, right? So yeah, this implementation, array implementation is chapter 4. Yeah. Okay, that is chapter 4. So chapter 4 says there is also a solution for that provided. Please check on that. Yeah, that is for B. You're supposed to create a program for solution to find solution to this problem, because if you were to set the values to constant, therefore there is basically no possibility of making it a span unless if you put it variable as in n. Okay. Okay, so how you could implement that, that would be to answer the question B. How can you rectify the problem? Identify it in A and then implement solution. Okay, so next question, 2A. Set is a collection of distinct objects. Typical operation on a set include, these are the operation that you can do in array. Okay, so you can add, you can remove, you check subset, okay, and then union, intersection, and empty. This is a array or list. Oh yeah, array. Okay, so a set. All right, did what happened here? Add add a new element to the array. Okay, so in order to see for question 2, you're required to write the specification for the set ADTs. What is boolean add t new element? What does that do? Okay, so you've been given specs for these ADT last week. I believe there is this document which states, or also in your lecture notes, what is boolean add t represents. Boolean remove t represents. Okay, so you need to write that specs for this particular ADT set. Okay, this is also theoretical. And then implement the set ADT, use array-based implementation for A. How are you going to implement that using array-based implementation? Okay, so this one, you need to have a code that can actually utilize Boolean add, okay, with this kind of characteristic t new element, Boolean remove t an element, Boolean check subset, set another set. Okay, so that is B is basically a sample of how you can implement that in a simple code. Okay, so that is for B. B is practical, A is theoretical. Next one, C, write a driver program to test your implementation of the set ADT. Right, a driver program to test your implementation. A while ago, you just wrote a simple implementation for each of the ADT set. Now you have a program that you can actually call all these functions to test your implementation of the set ADT. You get what I mean?
Yeah.
You get what I mean? First, this one is just to tell what is this function do. Next, you want to, for this particular function, okay, you need to write a short program which relates to how array is being added, and for an element is being added into the array. This is that tiny function. Okay, next one also similar to this one, how it can be removed and so forth, right? And then that is B, right? C, you need to have a driver program that basically calls all this function in your program to test your implementation of the set ADTs. You get what I mean? So just like how you wrote a while ago, right? You have the algorithm that wrote how your algorithm A, B, and C having that logic conditioning function. Okay, so that would be like this. And then you have a driver program, which you showed me a while ago, where you call all those functions. That is your driver program. Okay, so you implement what you have done here, put it into here by calling the function operation, what you have defined here, which is in B. And then you modify the Java interface and class from part B that your implementation provides an iterator to the set object. So then again, you need to add another criteria, which is iterator to the set object. Then include a method in your driver program that uses the iterator to display elements in that set object. So I think you have done this one, right? Method in your driver program that uses the iterator, display all the elements in the set object. Application on that, you can basically take also from your what program that you have done just now. Okay, so you only need to implement the has, next, and next methods of the Java utility that iterator interface. Okay, so next, what you have to do, refer to your table for that, like this. Can you see that? So you have a body of the driver program, which stores your this iterator, public interface iterator, that is your service, your interface, and then inside that you have your public boolean has next, public t next, public void remove. Okay, so this is your Java utility iterator. You're allowed to use this. It says here. That is for, let me see, for, yeah, practical 4. Last week, right? So this week, this one. No, this one is stuck. Yeah, this one. Okay, next week we will do this one. Recursion. Okay, so today's question would be this one. Practical 4, which I gave last week. So continue with that, yeah. And practical 5. All right. For next week, we'll do this. So I want you to look into this. If you can attempt 1 and 2, you may try to do so. Okay. So that is practical for today. So let me just write that down. Yeah. Under week 7. Week 6. Week 6, yeah. Are we clear, class?
Oh, I missed the chapter 4 sample code. Where? I cannot find anything.
Hang on, let's see. Chapter 4. Chapter 4. What is the sample code? Like, let me see. What is it required? That is under your
link.
under your, hang on a sec. That is under your lecture notes, right? What
Yeah.
are the lecture notes says? Let me see the lecture notes. What is the required for that? Okay, let's see. Hang on a sec. Yeah. Where is my code? Chapter 4. That's chapter 4, right?
Chapter 4, the array list. I cannot find the sample code again.
Really? Where did I put that? I thought I already attached. Hang on a sec, please. Hang on. Okay. Array list, I thought I gave already. Array queue, array list, yeah, I thought I gave. Let me see. Where is it? It is for chemistry. 4. Maybe up there. Two. 3. Oh yeah, okay, never mind. I thought I gave it already. Okay, never mind. I'll give now. Let me give now, yeah. Just at Practical material, practical people. Chapter 5, week 5, chapter 4, week 4. Create material. Which one is that?
The array list.
Is it linked? Huh? Which one?
The array list.
Array linked list. Array list.
Yeah, the array list.
List. Array list. Okay. Where is array list? Oh, okay, array list, right? What about array stack? Is it included? This interface, circular array. Okay, I really need to see my lecture first. Wait a second. Yeah, see what is the thing that I need to give you guys. That is under classroom. That is under chapter 4. Okay, so chapter 4 would be 3. 3, 4. Okay, array implementation of collections ADTs, right? So here, what the lecture notes says that is that you have these lecture notes, right?
I got the lecture notes, yeah.
Yeah, right? Yeah. Okay, then. Here, what you need here. This is what I meant, yeah, your ADT list specs. Can you see that? I think I gave this as well. Issues, exception. Okay, so list interface. This is chapter 4, list interface. Okay, let's just put that down. Interface. Is one. Okay, next one is this one. Need to just and
Oh, quite laggy.
right? If list,
Oh, Miss, not clear.
oh boy. Let's see your classwork. This draft right classwork. Materials. New materials. It's unbelievable. I thought I had given it to you. Let's see. Sample codes. Chapter 4. Yourself. What's the assignment? Just week 1. Runner.java is already there, right? Where is that? The array. Runner.java. See here. Runner.java is under your that chapter. Chapter 4, you have it already, which is in your week 1. Okay, and then registration as well, that is also in your week 1. Okay, because I remember I gave you list, interface, and array list, but let's see one by one. And then this is week 1, right? Let's see whether you have the rest. So we already have run and registration. We need list interface array list, right? Let's see. List interface. So then it is the stack. Okay, this one is under week 2. Okay, week 3. Okay, so week 4. All right, so I'll give you that one, yeah. You will need list interface to Java array list. Okay, wait a second, let me find that. That is Chander chapter 4. Chapter 4. Practical material. Source code. This interface, array list, this interface, array list, this interface, this. Ah, there it is. Interface and array list, array list. Do you need array queue? List interface. Okay.
Or the array queue already given in the
Oh, okay.
in, in the big 5 sample code.
Okay. So hang on. This is list interface I give you, and let me find another one which is array list. Yeah, list interface already uploaded there. Let me find array list. Array list is chapter 4. Okay, got it. Make a copy. Where is your, okay, that is move to classroom, and then high class, and then a source code. Move here. Okay, going to classroom, lecture, and then a source code. Ah, okay, array list. Let's rename that. Okay, so I added that. What else I need to add in? This interface. Okay, done. And then registration is done before. Runner is there. Array list. Array. Yeah. Okay. So next one is list interface. Yes. Array. Okay. What else? I forgot. Array stack. Array stack, right? Mm-hmm. Okay. Array stack. Now that's another one. Array stack, and then what else? Array stack, stack interface, array stack, string reversal. Array stack, stack interface. Okay. What else? Array stack, stack interface, string reversal. String reversal. Let's move this one first. Stack interface, array stack. Down into my lecture note, DSA source code. Okay. Array stack interface, array stack. Stack interface. String reversal. Array stack, stack interface. Stack, array stack, stack interface, stack interface. Okay. And then is the string reversal. String. Okay, that one so far has been attached. Let's see another one, string reversal. Sample code, that would be chapter 5, I think. Chapter 4. SRC. ADT. Code. Chapter 4. I cannot seem to find that string reverse is not here. For client, let's see. Client, client, client. Client. Chapter 4. Client, right? See. Client. Nope, not here. Okay, never mind. You cannot find that one. Yeah, I can, but I need to find that file. Yeah? But I already have some because all these files are scattered all over the chapters, right? So you have to search for it. Okay, but hang on. I upload whatever I have. The one which I don't have, which is referring to this one, right? Can you see this one? String reversal the Java. I don't have that. I don't know why they didn't put it in. So I upload what I have. Okay, this one Q interface Java also. I will add in. What else is there? Q interface. Okay, so many. Okay, never mind. I will do this in a second after a while. In the meantime, you guys can attempt the question which I have assigned, right? You can attempt the question for practical, which I have assigned just now, which is the, which one is that? 4? Yeah, this one. This one first, yeah? Do this one first. So in the meantime, I will upload the chapter 4. There's so many of them, see? Because some of them are also in the previous chapter. So I need to see share portfolio, share purchase. Some of them are not here. Share portfolio driver. Okay, so it is entity, entity, and client. Okay, so let me sort this out because I really think that I have already uploaded. I don't know where I have uploaded it, but I will sort this out. In the meantime, you guys do the assignment which I gave you guys for that practical questions. Yeah. Okay, I'll be right back and let me just find that code. I mean, sample code.